these do more than what these thin clients can do. So the only disadvantage is compared to the thin clients is that these are more costlier compared to the thin clients. Thin clients are cheaper, thick clients are costlier, and there is obviously more energy consumption, and there is some kind of management of these resources required. Plus you also need to secure these resources, because these can do more, so security issues also come up in an increased way compared to these thin clients. Okay, so some of these other essential characteristics, rapid elasticity is very important. So beyond network connectivity, you need to, as I was telling you, that so these resources, these will need to be provisioned and made available elastically, rapidly and elastically, almost without the end users being able to know what is going on behind the scene. And automatically there should be allocation of different computational resources from the cloud for the execution of the jobs or the tasks that are being executed. And there should be dynamic allocation and release for scaling in and scaling out of these different resources, right? So customers basically, they feel that they have access to the infinite amount of resources, computational resources. Actually it is not the case, but the way it is modeled is that if you need more, you get more. If you need less, you get less, and you do not really have to do anything proactively in most of the cloud platforms, right? So basically, this kind of rapid elasticity basically gives the consumers a feeling of being able to have access to an infinite pool of resources, right? Measured service I already told you, but just to elaborate further, the resource usage should be recorded and they should be monitored. There should be facility to dynamically control and optimize the resource usage, and there should be transparency between the service provider and the consumer, because it should not happen that the consumer feels that they have been inappropriately billed for certain resources that they haven't used, right? So that sort of transparency model has to be adopted while deploying cloud computing. So on-demand self-service is something that I already told you. Automatic provisioning of server time and network storage, and offering self-service. Resource pooling is another very interesting thing, which also we have touched upon already. So basically, you have automated pooling of all available resources which are participating in the cloud platform that is being built. And there is something called multi-tenancy, right? So we are going to use this term more often, but basically, so there are so many different tenants, right? So many different tenants, so multiple tenants, multiple end users, they are going to get serviced through this common pool of resources at the same time, without them being able to know that they have their resources that they are using, these are also being shared in the pool by other different users, right? Allocation of resources according to the user demand is made from the resource pool. Some of the differences between cloud computing and cluster computing. Cloud computing, so these are certain things that I would like you to go through once you get access to the slides. Just to do a little bit of overview at a high level. So cloud computing gives you heterogeneous resources, whereas in cluster computing, actually it is more of homogeneous resources. Why this difference is very important to understand is because people feel that what is there, right? So cluster, grid, and cloud computing, the way they evolved, they are one and the same. Actually it is not, and we need to understand that where is the line of difference between each of these different technologies. So it is not also that if you have access to cloud, cluster computing is useless. It is not that, right? So cluster computing is appropriate for certain types of applications, whereas cloud computing for certain others. So we need to understand what is the difference between each of them, so that we can basically adopt the corresponding technology. Cloud computing supports virtualization, whereas in cluster computing, actually there is no support for virtualization. And what is this virtualization? We will talk in more detail in the future classes, and I will show you one of our TAs. They will give you some demos about how virtualization is done, right? So we'll have some in future classes we will talk more about virtualization, because virtualization is basically core to understanding cloud computing. So we need to understand virtualization properly. Very low capex. I hope that all of you know what is the meaning of this term capex. Capex means capital expenditure, right? So because through cloud computing, if I need to get access to certain computational resources, high computational resources, I really do not need to go and purchase this capital equipment like servers, etc. Right? My capital expenditures is going to be very low. Whereas in cluster computing, actually I need to go and install the cluster. I need to form the cluster in order to get my job done, right? So very high capex in the case of cluster computing. Cloud computing security requirement is low, whereas in cluster computing it is more, and that is quite obvious also. And in cloud computing, the maintenance is also low, whereas in cluster computing, relatively high maintenance is involved. But these are actually from a user point of view. Remember that these are from a user point of view. There is support for multiple operating systems simultaneously in cloud computing, whereas in cluster computing, typically it is a singular operating system on which clusters run, right? In cloud computing, there is centralized and decentralized management, whereas in cluster computing, it is centralized management. In cloud computing, the scalability is high, whereas in cluster computing, the scalability is low. In cloud computing, there is a dynamic allotment of resources, whereas in cluster computing, these resources are tightly coupled. In cloud computing, application domain independent software provisioning could be done, whereas in cluster computing, application domain dependent software provisioning cannot be done, right? So this is actually, there is a typo over here. Okay. um, so and then comes there are a few other differences, like between cloud computing and grid computing. So in cloud computing, basically you follow some kind of a client server kind of architecture, whereas in grid computing it is the distributed architecture that is followed. In cloud computing, there is centralized usage of resources, whereas in grid computing it is a distributed usage of resources. In cloud computing, cloud computing is highly flexible, whereas that kind of flexibility is not enjoyed in the case of grid computing. Cloud computing, as per the units of usage of computational resources, one gets billed and one pays accordingly, whereas in grid computing, there is no support for pay-per-use kind of model. Then am I still connected? Can
Yes, sir.
someone
Yes,
confirm?
sir.
Yes, sir.
Yeah.
Yes, sir.
Somehow my
Yes, sir.
yeah. So this window disappeared, so I thought that let me get confirmed. Okay, so cloud computing accessibility is quite high, whereas grid computing accessibility is low. Accessibility of what? Accessibility to the resources, right? So accessibility is high, whereas grid computing, basically accessibility is low. There is support for multiple operating systems simultaneously in cloud computing, whereas again, like cluster computing, in grid computing also it's a singular operating system which basically powers these platforms like grid computing. In cloud computing, there is centralized and decentralized management, whereas in grid computing there is centralized management only. In cloud computing, basically there is support for high degrees of scalability, whereas in grid computing the scalability is relatively low. And in cloud computing, there is no involvement of middleware, whereas grid computing basically requires some kind of a grid computing middleware to power it. What happened? Okay, so these are some of these different differences between cloud, cluster, and grid computing. Now let us talk a little bit about mainframe computing, which came into existence in the 1950s, right? How many of you have heard about mainframe computing? Mainframes? Mainframes, have you heard about mainframes? Have you seen mainframe computers? Anyone who has knowledge of how mainframes work? You need to interact, okay? Otherwise it is not going to be fun. Let us try to, otherwise it is going to be only one way traffic from me to the students. I also need to learn from the students, right? So any student who has experience with mainframe computing?
Sir, in the CIC, do we have a mainframe?
So that is a question that you are asking back to me, right? So my question to you is that do you know what is mainframe?
It is a
No, I
central
mean in
computer
our
to
first
which
year CDC,
Hmm?
PDS lab,
Can you
we
speak a
use
little loudly?
enough
Who is
in our
speaking? First of
first
all,
year PDS lab.
no, no, who is speaking?
Piyush Ranjan.
Yeah, Piyush. Yeah, please tell.
So in our first year PDS lab, we used Ubuntu, Sun Lab Ubuntu kind of thing, OS, and like
Yeah.
I guess it was like all the users ran on a mainframe only.
No, you
it
tell me
is
what is a mainframe?
sir, I'm Otanu. It is a central computer to which terminals are added, and simultaneously a number of users access the computer. Like this is being used for COBOL computing and all.
Yeah, yeah. So how many of you have heard about COBOL? Anybody who has not heard about COBOL? So do not raise your hands through this thing, because so it becomes difficult for me to track. So so just speak up, right? Anybody who has not heard about COBOL? So COBOL, actually, Sontu, you are smiling. Do you know COBOL language? Did you
Sir,
study
I
COBOL?
heard about it, but I haven't used it.
Yeah. Anybody who knows COBOL programming? Just curious.
Sir, I was in diploma and we had a course on COBOL, but the unfortunate thing is that we did not have the access to mainframe.
Yeah.
Sir, this is Nidhi.
Mm.
I have worked on mainframe in Infosys. So
Oh,
I
yeah.
worked on COBOL, JCL.
Yes, 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 yes. So typically, who was the client? Some bank?
Sir, McDonald's.
McDonald, yeah. You see, so typically, so mainframe computing is gradually, it is phased out right now. But so it was popular for applications like banks, etc., right? And COBOL basically was the language for powering mainframe computing, right? One of the popular languages, right? I do not know. I myself, actually, I will tell you that I do not know COBOL as such, but during my student days, we got little bit of exposure to COBOL programming, but it is kind of obsolete right now, right? Even the mainframe kind of approach is also almost obsolete, except wherever there are legacy systems which are still being continued to be used, right? So there are many places, actually, banks, etc., even maybe McDonald's also. I do not know where there are legacy systems which were built maybe in the 80s and so on. So they are still trying to maintain those. So in those cases, actually, COBOL programming, one needs to know COBOL programming. People who work in these consulting companies like Infosys or TCS, and if they have a client like this, they basically will have to learn, and they will have to support through COBOL, right? So but as such, actually, COBOL is not that popular at present, right? Nowadays, everybody talks about most of these Java based platforms, right? So anyway, going back, yeah. So mainframe computing, basically, it concerns highly powerful and reliable computing machines which can basically execute multiple massive input-output operations. The fault tolerance is very high in mainframe computing. So basically, mainframe computing was replaced by cluster computing, and as you know, the cluster computing also gradually, the popularity has reduced a bit with the evolution of cloud computing. Having said this, I also should remind you that it is not always the case that in all kinds of scenarios, you do not want cluster computing. It is not like cluster computing is gone and gone forever, not like that. But now, because of cloud computing, basically, everybody tries to take advantage of cloud computing for getting some of these business issues resolved in terms of their IT infrastructure, right? So Now let us look at some of the different components at a high level of any kind of cloud platform. So you need, so at the very bottom, what you need is some kind of an infrastructure, right? So this infrastructure will need to be offered, right? So in this infrastructure layer, it concerns doing some kind of a virtualization. So virtualized resources corresponding to the infrastructure will need to be provisioned and will need to be made available to the end users. So that is where basically this infrastructure as a service comes into picture. Then you have storage. So storage, basically, you need to have some kind of storage mechanism, some databases, etc. And that is where the concept of something which evolved later on, which is called the data storage as a service, DSAS, that actually came into being. So some kind of a storage, and the storage being made available to people for use. Platforms like apps, web hosting, etc., using platform as a service. Then applications like web apps or software as a service. And then you have the services like different products and solutions, and at the very top are basically these theme clients, etc., which the end users they are going to use, and they are going to get connected. So even now some of these accesses are also made through mobile and stationary devices. So so nowadays, everyone uses cloud, right? Whether we know explicitly or not, many of us, we are using cloud, right? And for example, the Gmail service, Google's Gmail, right? It's basically an instance of cloud-based email service, right? It's an instance of cloud-based email service. So Gmail is basically Gmail is an example of software as a service for offering email services to users. So anything that can be served as a service, in terms of the computational power to computing infrastructure, applications and business processes. So these are all these are all made available through the cloud, and anybody can get access to these different required resources depending on what they have to do. So only there are two constraints. Number one is that there has to be some kind of a common standard which will have to follow, which will have to be followed across, and there has to be some kind of an automation which will have to be installed, or which will have to be deployed. Some kind of an automation will have to happen. So standardization, basically, as I was telling you, that there has to be some kind of a consistency, some kind of a standard for service delivery. There has to be consistency in terms of the interfaces, and this is necessary for both before and after deployment. This standardization basically is very important when you are talking about a common platform like cloud. So many areas of standardization involve service calling, service interfaces, resources, and network management. So there are typically 6 layers that need standardization. The motive is to have some kind of a scalability, interoperability, and security in the cloud. So there is a lot more which I am going to carry on in the next class, which is tomorrow. Tomorrow I am also going to talk about the project. All of you please come prepared. So I am going to talk more in detail about the type of project that you are going to do. So we will have a lot of flexibility in terms of the project. We have deliberated between ourselves, what sort of projects can be done. I myself, I am going to give you some of the ideas about the different types of projects that you can do. Additionally, if you also want to do certain projects, we will make it, we'll keep it flexible for you, because so right now, when many of you are working remotely from your homes, you do not really have access to some of these resources for doing the projects that you would like to have. So that is the reason actually I will keep it more flexible for you. But at the same time, basically it also becomes some kind of some kind of a measured evaluation, right? So if you it's going to be relative, right? If you do something which is more difficult and challenging, you get more marks, and if you do less, you get less marks, right? So And that basically, you know, I will have to ensure that that happens. The reason being that some of the students, they will be basically working harder than others in order to execute certain projects. So I have to reward them more compared to the others, right? So that's all about today's class. So now we are over time, and next class, that means tomorrow, you know, please come prepared by having a look through whatever materials we have covered so far. Okay, so thank you, and see you tomorrow.
Thank you, sir.
Thank you, sir.